I'll take that as a no.
Okay. We got one section and 6 to finish, which I don't know if you remember what I told you it was about. It sounds really exciting. It's the factoring word problems. Yay, Jeff! So here's an example of this. Say a rectangle has an area of 54 square centimeters, and length. Oh my gosh, Jeff, what word is that?
So this is 6.7 then?
6.7, yes. The length is 3 more than the width. 3 centimeters more than the width. Find the dimensions of this rectangle. So obviously, hopefully, a really good first step is to draw a rectangle. And then next to it, what's the most important first step in a word problem?
Write it out.
Right, whatever.
Or like
the players.
The players, I love it. And of course, what are the players in this problem?
The length. The dimension.
The length and the width. The length and the width are the dimensions. So they're the things I don't know. Right? So length, width. So word problem, the first few steps of word problem doesn't change depending on how hard it's going to be or what it's going to use. It's in this section, so I know I'm going to have to use factoring somewhere. But it doesn't change the setup. I draw a picture. What are the players? What's the next step? Who's going to be just
the variable?
Yes. What's going to be just the variable? It could be x or whatever you want to use. So what's going to be just a letter? The width or the length? The width. Okay. Right? And this is one of the ones we dealt with this a lot before. Hopefully you can see it very quickly. The length is something to do with the width. So I got to know what this is first. What do you want to call him? W. I love it. So then what's the length?
3LX.
Whoa, no. What's the width?
W.
And the length is 3 more than that.
3W.
Not 3 times that,
3 plus.
3 more than that. Yeah. 3 more than the width. Don't do that to me.
Sorry.
That's right. Okay. And then if I wanted to, I could label my little picture. Oh, little picture. All right, now, this is where, this step isn't different. It just results in a different type of equation that we now know how to solve. We never did an area problem in word problems before. It was always perimeter. What is the area of this? Don't tell me 54. Okay, that's great. Yeah, no numbers. But what is it in symbols? What's the area of this?
W times W plus 3.
Yeah, so the area is, now I put,
W squared.
no, what is this supposed to be? 54. Now I've got an equation to work with. I have 2 ways to represent the area of this rectangle. The number they gave me and in symbols. And of course they have to be the same. It's the same stupid rectangle, so any way you talk about the area, it's got to equal itself. So the area of this must equal the area of this. Maybe. It's the idea behind modeling. I know what it is numerically. I just have expressions that relate what they are, so I got to set those equal to each other. Now I can solve for what W is supposed to be. How the hell do I solve it?
Distribute.
Good. Why?
Because you have to find out what the width is first.
It's not equal to 0. So I got to distribute, suck the 54 over. Right?
Oh, Jesus.
Who to what? No Jesus. You guys with me? I mean, this is, again, I know this isn't what happened, but if I look at that equation, it looks like somebody factored too early. They factored before it was equal to something. Unfactor it. Subtract the 54 over. So what do you get here?
W squared plus 3W.
And then let me subtract the 54 over. Now I can factor this. Right? Hopefully.
Did you know the Jonas Brothers got back together?
Say again?
Jonas Brothers got back together.
Oh, the Jones Brothers? That's all I was thinking about the whole weekend. That party.
It's an epidemic, man.
I was wearing my. Which brother do you like the best?
Joe.
No, none of them really.
What?
None of them. I think they're all terrible.
Oh, so you don't discriminate. They're all equally terrible.
Yeah, I just like this music. Music's good.
Just remember the hands. Bob. All right.
You like that kind of.
Always, yeah, I live for it. So let me do this part. WW, I got W squared. What numbers do you guys get? Minus 6 plus 9 makes negative 54, adds to be 3. So what am I getting for the width? I'm getting the width is either 6. Now, if this is a question about what numbers make this equation work, those are both good. They're both numbers. But this is a question about a rectangle and the length and width of it, so of course I throw out negative 9. Right? If you can bring into me a rectangle that has a negative 9 width, that'll freak me the shit out, but then I'll let you keep that answer. So this is true mathematically, it just isn't true physically. Right? So the width is 6, am I done?
No.
2 things.
Plug it back in.
Yeah, I got to figure out the length, and I also have better put on there units,
Centimeters.
right? So the width is 6 centimeters. What's the length? Who?
6 plus 3.
6 plus 3. Let go of that. That's not a part of this answer at all. What's negative 9 times negative 6? Negative 9 times negative 6. That's another way to get positive 54 is negative 9 times negative 6. Why can't I use that for this problem? Because it's a physical problem. I like it. So math always gives me all the options, and I pick the ones that actually work for the situation. 6, and then this will, of course, be 9. Checking it, it works.
So how come it was negative 6 and positive 9, but then you switched it?
No. I really want... So what step am I skipping here that I want everybody to get to the point where they don't have to do this? How do you do this? You say either this is 0 or this is 0, and then you solve. Add 6, that's where I got 6 from. Yeah. So you can throw that out. You can generalize that to realize that if I had x minus 7, it leads to 7. X plus 4 leads to negative 4, right? You gotta be a little careful. I got 5x minus 8. I might want to set the equation up for myself. Okay, maybe.
Maybe.
Good. Stretching.
Is it always going to be so easy which one to tell to throw away, like say the negative 9 and the 6?
I would never say yes to an always question, but most of the time, yes. I like it.
If it breaks like the physical.
Yes.
Yeah.
Yes. Now, how did I create that problem? I mean, did you guys see me reference notes to make that problem?
Yeah.
So what I did was this. Somebody help me out. Somebody help me create a rectangle. What do you want the width to be?
5.
Give me say again.
5.
5. Now somebody else tell me what the length is. 11. You're so freaky. Sorry, because that's exactly what I was thinking. Yeah, in my head. This is a really good ability to have, is to read your math teacher's mind as you're taking a test. Okay.
Wait, what'd you get on that? See? Yeah, you can read your mind.
I know, man.
Yeah.
I got to start wearing me the Magneto thing. Stay with it. Come on. I'm sorry. I'm always the worst distraction. I'm sorry. Sometimes. So can you create a relationship between these two? Yes, you can create an infinite number. What's the most obvious relationship between the width and the length for this rectangle that you guys made for me? What's the most obvious relationship? The length is, you can do 6 more. Do you see? So what kind of word problem could you? And what is the area? We know what the area is. What's the area? Let's make this feet. So what's the area?
55.
55 feet. So what would the word problem be? One word problem you can use is the area of a rectangle. Let's try to be a rectangle. is 55 square feet. Yeah, there. And the width, let's say the length, what do you say is 6 more than
The width.
the width. Find the dimension, same question, right? And it would work the exact same way. Now, real quick. Now let's see, what would it look like? It would look like width, what would the length be?
W plus 6.
Then I get W times W plus 6, that's the area from this, has to equal what it is physically. I'm doing this a little bit quickly, because it works the same way as the other one, right? I have a place I'm going here in a minute. So you get negative 11 and 5 throughout the negative. So I get 5 like I knew it was supposed to be, and then plus 6 will make 11. Now, watch. That's not the only relationship for this. I could also say the area is 55 square feet. The length is 1 more than twice the width. Double check me on that. Is that true?
Yes.
Yeah, twice the width is 10. 1 more than that is 11. So now what would it look like? It would look like W twice the width plus 1.
Oh.
Right?
Yeah.
Now, I just want to show you this real quick, because this is the thing about modeling students don't get. Both of these represent the same rectangle. How many ways is that? There's an infinite number of sentences I could put here. Because what's 3 times this? So minus 4. So it's 4 less than 3 times the width.
Oh, Jesus Christ. That's what it is.
No, don't freak out. You're never going to have to create your own word problem.
Oh, you're scaring me, dude.
You know me by now. You know I do these weird things where I show you more. Why do I do that? So you have a deeper connection with what you're doing. And if I do this, what's this going to look like? Multiply those together. It's still supposed to be 55, right? Now the factoring is going to be a little bit worse, because I'm going to have a 2 out front. Is that cool? Oh, baby. So take a minute and factor that. It's gonna be so I think that word means triplets. Sorry, guys. Believe it or not, it shouldn't be that evil. Whatever the middle number is 1, that's actually really kind of cool. That means it's a negative, right? So they have to have 2 numbers that are 1 apart that multiply to be 110. What's the easiest way to factor 110? 10 times 11. And which one's negative to make the middle come out positive? It's the evil way to say that, but all. 10's negative. The smaller one's negative. I like it. You guys semi with me? Alright. So then I get 2w squared minus 10w plus 11w. I'm going to do this a little quickly, alright?
Why'd you get 110?
2 times negative 55.
Okay, but if you use it, why is it still there?
Where is it still?
Do the rest. You just used it.
Used what? Sorry.
Sir, I'm confused. You just said that you used the 2 that is in front of the first w, that is w squared.
Totally.
Right. So
Yes.
if you used it, how is it still there?
I didn't.
It's
Alright.
like eat the candy bar and then still have it.
No.
Okay.
I didn't need it. Right?
Okay.
You with me?
Yeah.
I just said I can't just find factors of this.
Okay.
As we discussed before, when the first number's not a 1, it's going to mess my middle stuff up.
Gotcha.
So how do I undo it? I got to take into consideration from the beginning. So
Gotcha.
instead of factors of 55 that had to be the middle, I have to find factors of 110
Okay.
that had to be the middle.
Gotcha. Got you now.
Now I'm going to rewrite this, so it's still 2w squared. I can't magically make the 2 go somewhere else. It's still 2w squared, it's still 55. In the middle is still 1w. Just what's another way to say 1w? Negative 10w plus 11w.
So we're grouping.
Now you can group.
Okay.
Yes, that's the AC method, the big X method, surefire method, or whatever you want to call it. Right? Or if you've decided, that's just one method, I'm just not going to learn it. All right, shit, whatever. Just make sure it shows up everywhere. So then what comes out of these two? 2w.
Plus. W.
Good.
Plus 11, W minus 5.
So we get w minus 5 times 2w plus 11. Let me see if you guys can get this. This will lead to what? 5. This will lead to subtract 11 divided by 2. It's negative, so who gives a shit? I can throw it out. For this problem, right? Don't start throwing negatives out everywhere. This is a real world problem. I can't have a negative. Now, for every word problem, the negatives get thrown out. If you have a company profit, can profit be negative?
Yep.
Oh shit, yes. So you got to be careful. It's not just because it's a word problem I throw out the negatives. It's because in this word problem, negatives don't make physical sense. Okay, I like it. So then I get the same answer. I get 5. So this will be 5 feet. And 2 times 5 plus 1 is, of course, 11 feet. Stay with me now. I guess I'm hoping you understand there's this idea about modeling a situation. How many different ways is there to model a situation? Infinite number. But if I know what the answer is supposed to be, no matter what the model looks like, they have to come out to be that answer. Just depending on if I use a worse model, it's going to be a little bit uglier to tease it out. Maybe. Okay, let's try another one. Okay, I like it. Let's do this one. You got a triangle. You need a teeth of that. That's area. Which gotcha? 30 square millimeters. I gotta know what. Okay. The base is 4 millimeters longer. How do you get a T in the word longer than the height? Find the dimensions of the triangle. So draw a little triangle. All right, your triangle could look different, but what are the players?
Base and height.
Base and height. That was nice. Now which one is going to be just a letter?
Height.
Why?
Because
So the base is
Base
4.
is blah on the height. So I got to know the height first so I can do the blah to it. So what do you call it? You want to call the height H?
Yes.
You make it capital H just to help me out. And so what's the base then?
4 mm plus b.
Yeah, you don't put units in the math because the units just kind of make it look like there's more variables, right? So H plus 4. Now here's the trick. Try to set the equation up. It's not the same geometric shape as what we just were using, so the formula might be a little different. Hopefully you remember what the formula is for area of triangle.
Base and height.
We're everywhere. Okay. So, given a four-sided figure, the area is base times height. So a rectangle just happens to be one where the height is this side. So that's why it's length times width. How does a triangle relate to this? It is exactly half of it. So the area of a triangle is 1/2 base times height. So for any triangle, if I duplicate it, turn it over, put it next to itself, I've now made a quadrilateral. I've now made a parallelogram. So it's half of the area of that parallelogram, always. So, what's the equation look like? I know it's going to equal 30. 1/2 h
H plus 1.
h plus 1. Hello. Now, that's where people freak out a little bit. First thing I would do, if there's a problem in my equation that I don't like, I kill it. It's an equation. I'm allowed to kill things. I don't like that 1/2. So instead of distributing 1/2 and everything, getting all freaked out, how do I kill the 1/2? Multiply by 2. Yeah. So we get h squared plus 4h equals 60. All right, finish it up.
How do you get the h squared? Is it from multiplying?
Yeah, so now I distribute. Good.
So wait. If we do it to just the fraction, that's it?
No, you ready? I love it.
You don't have to do it to everything else?
I did it to everything.
I don't like that laugh.
You ready?
Alright.
What's double 10?
20.
20. So anything I put here that is 10, the answer better come out to be 20. So if I say what's double 5 times 2, the answer better be 20. But if you double 5 and double 2, you get
40.
holy shit. I only have 1, 2. It can't double both. What are you doing then? You're distributing, but there's nothing to distribute. It's just multiplication. It's not addition. You don't distribute across multiplication. So what is 2 times all of this? The 2 immediately dies. Right? It's like, Fred, go get him. My friend's dead. Shit. He died right away. So he can't keep going. He's dead. It's really good though. I mean, it gets a little confusing because you're used to distribution and all kind of business. Everything's multiplying there, right? So remember this. You can't do 2 times 5 and 2 times 2. 2 times 5 is 10. That 2 is in there already. You like it? Maybe? Another way to think of this is, don't I currently have half of this? Isn't that what that says? Half of this. So what do I get if I double it? A
Double.
whole one of those. Whole one of those, right? I get this, a whole one. Not half of it, I get a whole one of those.
Gotcha.
I like it. And now finish it up. Did I already say that? You guys done? No?
I don't want to die.
This one should be kind of in your face a little bit. The easiest way to factor 60 is 10 and 6. Since it's negative, they're going to be different signs. You're going to subtract to be positive 4. So which one's positive? 10 or 6?
10.
10. So you get height is either
-10.
-10
Or 6.
or height is 6. So then the height is 6.
6 plus 40%.
The height is 6 millimeters.
Oh, you're looking for that part.
And the base is 10 millimeters. And then you check it. What's half of 6 times 10? 30.
Now we see now.
I like it. So of course, how did I create a problem? You now know how I made that problem. I started with a triangle that existed, right? 6 height and a 10 base. So that's how I created this 4 millimeters longer, and that's how I already knew what to put there as a number. Okay, I like it. I like it. All right, let's try a different type. Let's see, what other kind of weird types do we have?
Circle, parabola, octagon, trapezoid. That's all the shapes I know.
Yeah, that's kind of dumb. Let's see. They
Oh,
basically have
rhombus.
all the same.
That's one. That's a shit. You take any more shits?
Oh, here we go. Perfect.
Where's the elbow when you need
Alright.
it?
All right, let's see. Okay. All right, here we go. They really love these ladder problems. So here I have a house. I have a ladder resting against the side of the house. You see. You can say no.
That's gonna fall.
Yeah. So that ladder is 26 feet long, and this is 10 feet away from there. How tall, how high up does it hit the house?
Wait, so what's what's
So-
the word problem?
The ladder is 26 feet long, and it's resting against the side of the house. It's 10 feet, the base of the ladder is 10 feet away from the house. How far up the house does the ladder hit? What kind of triangle specifically did I just create?
Right angle.
Right. And that's cool, because we know a lot of shit about right triangles.
A squared plus B squared equals C squared.
There's a slight modification to that formula if it's not a right triangle. I say slight, it's actually kind of chunky, but you'll learn that if you take trigonometry.
Chunky Campbell soup.
So what is this? We don't know. So what is this? What's his length? What's his height?
X,
Doesn't matter. Yeah, let's call it h. The square doesn't come in until you set up the equation, right? So how exactly does the equation get put together? Everybody's cool with Pythagorean Theorem, right?
Yeah.
A squared plus B squared equals C squared. So a really cool visualization of that. Let me see if I have enough room here. Maybe. I don't know if I've done this for you yet. I don't think so. Imagine there's a square coming off the sides of each of these. I've almost got enough room. Right, so this is a square. It's A by A. You guys with me? So what's the area of the square? A squared. Area of the square.
B squared.
Area of the square.
C squared.
So what the Pythagorean theorem says is that the area of that square plus the area of that square equals the area of that square.
Huh.
And there's this really cool thing somebody constructed where you turn it this way with this on the bottom and it's full of water. And if you turn it over, all the water goes up and completely and totally fills these two up. So the water here equals the water in those two things. It's a really nice visualization of this. This also helps you remember why they're all squares, because they're all squares. Right?
Oh.
Visually, they're all squares. So why does the formula get squares? Because they're all freaking squares. Right? So A squared plus B squared equals C squared. What's the most important side?
C squared.
The C, because it's the only one that's by itself. So what's C up here?
26.
26, I love it. So I got h squared plus 10 squared equals 26 square.
Two more figures of the inch.
676. Is that 26 squared? Somebody help me out? 26 squared. Anybody have a calculator on it? I think it's 676.
I thought you were a human calculator, John.
She just said it was right.
Oh.
I'm no human calculator though. I can just pretend like I am sometimes.
Subtract the.
Yep, subtract 100. And now you got to take a square root of this. Which is kind of like why this problem is a little evil that it's here, because we actually haven't talked about square roots yet. But you got a square root button in the old calculator. I think it's 24. Yeah, it's got to be. This is 7, 5, 12, is it 5? 12, 13.
It's 24?
Yeah. Yeah. Yeah.
Dang, dude, how do you just remember all those?
All right, watch this. You ready? Is everybody decent with that? 24 what?
Feet.
Feet. No square. It's a height. It's not 2 dimensions, 1 dimension. You guys, all right. So most you should know Pythagorean theorem, right? A squared plus b squared equals c squared should at least sound familiar.
Yeah.
There are certain triangles where the sides are nice whole numbers, like this one. That's a base Pythagorean triplet is what it's called. It's a Pythagorean triplet. Ooh, because there's 3 numbers. Ooh. 3 squared, 9, plus 4 squared, 16. 9 plus 16 is 25, which is 5 squared, right? If I just put 2 numbers on the side of a triangle, this is going to come out to be some gross square root. But 3, 4 comes out with 5. 5, 12 comes out with 13. 12 squared, 144, plus 5 squared, 25 is 169, and that is 13 squared. Now what's twice 13? And what's twice 5? So what's this going to be? Twice 12. 24.
Oh.
That's an example of the more you know, the less you have to do. Right? If you knew this base thing existed, and you saw the ratio of these were 5 to 13, you know this has got to be based on 12. Are you guys semi with me? Even if you don't get that, you still got a way you do it, and I'd rather you do it this way anyway, because it's all about, can you get to the answer? Now here's a really good problem. Oh shit. Here's a problem I would give you for a test. That one was too easy. Here's a triangle. What you got, Jeff? I don't know, man. Yeah, sure. Alright, find out what x is. Just to warn you, I love this problem. Gotta be real careful. There's a trap you guys fall into. So let me make sure everybody's on the right track. What's the equation you're gonna write down? X squared. For some reason, once this kind of thing is in the middle of other stuff, you guys just put down x squared plus 4 for that. You know that's not x squared plus 4. Stop it. You gotta write this twice and FOIL it, right? So you gotta do this. But the minute I put that in the middle of other stuff, part of your brain goes, no, it's gotta be easy. This other shit, no, it can't change. That's how you do that. Keep going. Start to catch up to you guys. I put these together, but one of these dies, right? You get 2 minus 1 is 1, or you just get 1 left alive. Is that cool? I could subtract x squared, they would kill each other, right? Then I subtract 8x. I want everything on one side. Why? Why am I doing this? Yes, because I have a squared x, so I got to get it equal to 0. And now it's all about factoring that thing. Factor that thing. inherent in this is a physical triangle I've drawn, so the answer has to make physical sense. Yeah, what is it?
X minus 6.
So x is either 6 or x is -2.
It's a little fast, but
A -2 freaks out for a couple reasons. A side would be negative, but then this side would be 0. Okay, that's really not making any. It wouldn't be a triangle then if that side is 0. It'd just be a line. Do you guys see that? So you got to throw this sucker out for a couple reasons. So x is 6, and that's really all I wanted from this problem. There's not another part to this. I didn't give any units. X is 6. You're done. What kind of triangles it make? 6,
8,
8,
10.
10. 3, 4, 5. It's just twice as big as a 3, 4, 5 triangle. Okay, maybe. Does that sound at all familiar? Anybody 3, 4, 5? 5, 12, 13. There's some other ones, yeah.
I know 45 is why
30.
the sides flip it now.
Which signs?
Yeah.
Oh, okay, again.
He's skipping. He's doing it in his head, okay. You like
but-
just subtract.
And this is my fault a little bit, but I want you guys to be able just to get there. How do I solve anything like this? I say either this is 0 or this is 0. Solve this equation, add 6. So what's the quick way to look at this? What makes this 0? 6. What makes that 0? -2. Because if either of them is 0, then the product is 0, right? I like it. So I'm not changing the signs. It's just that to solve this, you got to add it or subtract it.
Why didn't you combine the x squared on the one side?
Oh, I told you. What's x squared plus x squared? 2x squared.
Yeah.
Minus x squared,
Oh, gotcha.
x squared. So if I kill it, then I have less work to do, but it doesn't matter. You just get there anyway. Either way you do it. I like it, maybe. One thing about equations, that's basically what I've learned over all my time, is if there's anything the same on both, I just kill them right away. So I have less shit to look at. I don't care if there's like terms, 8x and 7x, and they got an 8x, kill the freaking 8x's. You got less shit to look at. That's something we don't teach because then it leads to all these weird mistakes students can make. But when you get comfortable with equations, you're like, well, yeah, I'm going to kill whatever's the same. Maybe.
When there's an equal.
Yes.
I know you lost.
When there's an equal
When
sign.
there's an equal sign in the middle.
All right.
Yeah, if it's just next to each other, you can't cancel them unless there's division or something like that. They're on the same side.
So let me let's leave word problems for right now for a little bit until next time. Chapter 7. Oh shit. We've looked at this next problem before. X can be 0 in this all day long, because that just makes it 1/7. What can't be 0, though?
The denominator.
The denominator.
So x can't be -7.
Exactly. So watch this. In English, denominator can't equal 0. Is that cool? That's in English. Then I write, so what's the denominator? X plus 7. Can't equal 0. Solve it, right? I don't know if you guys realize this is a question about domain. Do you see that? What does domain mean? All the x's I'm allowed to use. So what's the first step we use very often in domain is figure out what I'm not allowed to use. And the domain would be everything else. So almost anytime you have a domain question, if you can say in English what has to happen, write that in Mathish and solve it, you got the answer. So subtract 7. X can't be -7. Now, do we have to write this? Not really. Most of you guys could see -7 will make the bottom 0. Well, what about this one? I don't know, Jeff. Yeah. Yes, sir.
Can't you multiply, what was it, 2 over 1 to get rid of the 2x sometimes?
Say it one more time.
I was like, can't you multiply, I think it's like 2 over 1, yeah, 1 over 2x. Get rid of the top or not?
I mean, I could, but why?
Because it'll be easy.
What would be easy about
Because
that?
if you really like, if you don't have it as a fraction, right, it'll be easy.
Oh, all right, real quick, a little side note. You ready? Because I know exactly what you're talking about. This mistake happens a lot. There is no reason I would be allowed to do that. But if the problem was this, right? What happens? If that's the problem, they say simplify this. What happens?
With 2x.
Two x's cancel. Your answer is not this. Your answer is never going to freaking be this, because where is that?
That's the denominator.
That's the denominator. So it's still the same problem. Oh shit. But no, I appreciate, Chris, it's not, I love the thought process of how can I make this problem easier. It's just you got to be really careful about being too optimistic about what really is going to help and if I'm allowed to do it. But the top doesn't mean shit to me in this kind of problem. It doesn't mean a damn thing to me, because what's the only way a fraction can have something that's not allowed to be used if that value makes the bottom 0. I don't care what happens to the top. So I could have put. All right, and I'm going to do the exact same work because I don't care what's on the top. What makes the bottom 0? So if I take the bottom and I say that it cannot be 0, how do you solve that? What do you have to do? Factor it. Beautiful. Do it. So now you start to see. This is the first couple problems in chapter 7. And what are we doing already? Factoring. Chapter 7 will involve factoring everywhere. So if you hate it, I am sorry. You're going to have a rough time. Just to be blunt. Oh, that's what's going on. They won't make negative 5 though.
I just, yeah.
8 and 3. Good, negative 8 to make it come out negative 5 in the middle. Good. And then you break up the middle, so the first part stays the same, the middle part you break up. Oh, they broke up. And then you group. I love it. Right? So take 4x out. Plus 3. So you get 4x plus 3. That was x minus 2. Can't be 0. You want to use this to erase. It's not going to work. So therefore, so I get here. So therefore x can't be 2. Is that cool? And then this one, you could write the equation down, but I know I'm going to subtract 3. And then I'm going to divide by 4. So I know it's going to be negative 3/4. So x can't be 2 and x can't be negative 3/4 because that would make this fraction undefined. I like it, I like it. So anytime we start talking about these, the very first thing we have to talk about is, what does that mean about the values I'm allowed to use? Polynomials. I can use whatever I want to. These, what am I going to call these weird things? What do I call officially a number like this? Don't say fraction. What's the official word for that? What is this? It's a what of two things? So 3 cups of flour, it's every 4 teaspoons of sugar.
Parts of whole.
True, but it's a ratio. So this is a rational number. So what is this? This is a rational expression. It's a ratio of 2 expressions. So it's a rational expression, a ratio of 2 polynomials. Oh shit. And what are we able to do with fractions? One thing is make sure the bottom isn't 0. That's what we're doing. What's another thing I can do with fractions? Very standard fraction problem. More standard than adding 2 fractions or subtracting or multiplying. I can just, or dividing. What's the most basic thing we do with fractions? Simplify, reduce. Right? So watch this. This is really cool. Or at least I think so. I know, my definition of cool is a little different. I understand that. Let's remember. So how do I reduce 3? Let's say, how do I reduce 30 over 45?
Divide by a common.
Yeah. So let's show ourselves a little more work than we normally do. I'm not going to change the work. I'm just going to show myself more work. So what goes into both?
5.
Okay, let's start with 5. 5 times 6 over 5 times
7. Oh, no.
9. And why am I allowed to reduce? Because 5 divided by 5 is 1. So I mean, that's what we're really doing. We're reducing. Now, really, exactly why did the 5s cancel? Exactly why did the 5s cancel? And you're all like, what the hell do you want from me, dude? It's what I always do. What's the bar mean? And what's the dot mean?
Multiply.
So of course they're going to kill each other. You can only cancel something if you have opposite operations. All right. And of course you see you can do more, right?
Yeah.
3 times 3, 3 times 2. So it becomes 2 thirds. Now, can I reduce this? Not a trick question. Can I reduce that?
No.
No. Even if I write it a different way, I should be able to reduce it. Even if I make it 5 over 5 plus 3, can it cancel the 5s?
No.
Of course not. Why not?
Because they're connected to the 3.
No connection. These are connected too. But the connection is
5 can't be divided.
addition. Is division the opposite of addition? No. So of course they can't cancel. So you might kind of scoff at it and go, I would never do that, Jeff. But all day long, somebody would do it here. No. Because variables are numbers. Whatever you're not allowed to do with numbers, you are also not allowed to do with variables because variables are numbers. But when I write it like that, your brain goes, everything's different now. And I don't like this. I'm going to kill them. No. You're not allowed to do this, you're not allowed to do that. So, watch this. What am I allowed to do then? I love this. You're all like, we know you love it, Jeff. Shut up. Let's see. Yeah, I like that part. Okay. Now, I don't care how often I say this. I would love it if you, as a class, proved me wrong about what I'm about to say. No matter how often I say this, I'm still going to have somebody that cancels the x squares. Just kills them. Right? And then reduces the 9 and the 15. Why can you not do that?
Because they're connected by addition and subtraction.
And division can't kill those operations. So what can I do with the top and the bottom so division can do something?
Factor.
Factor, because then I have multiplication, right? How do I factor the top?
X minus 9, I mean 3.
X minus 3.
Cool. All right. Whichever order you want to put those two in. How about the bottom?
X
Yeah, x plus 3, x plus 5. Is it cool? No minuses, everything's positive, right? And now you can kill something because you have multiplication and division. So what's going to die?
X plus 3.
Die! Now, real quick, I've done this before. I want to show you one more time with this. This is kind of cool. What's the only things x cannot be?
-5.
-5.
And 3.
-3. I know they cancel here, but only if it wasn't 0. So I'm going to pick a number. Let me pick 6. I've done this before, right? This is all extra shit. You're never going to have to do this by yourself. But if x were 6, what's on top here?
squared.
6 squared. What do I get? I get 27 over 36 plus 48 is 84 plus 15 is 99, I believe.
And then simplify.
Yeah, and let's see what we get over here. What if x is 6? What do I get here? 3 over x is 6. 11. And if I reduce this, what do I get? 3 11s, yeah. No, yes, maybe. I know that does not mean that this is some horrific new way to reduce 27 over 99. No. This is a way to reduce any fraction that looks like this. So I can make x any number I want to except -3 and -5. And every time I make x a different number, I get a different fraction. And I would have to reduce every one of those. Or I could just reduce it right now. Bam. And then whatever x is, I just put it in there. You guys I know, that's extra shit. You never have to do it yourself. But it's always nice to see the concrete reality behind what it is we're doing. You guys are all like, Jeff, we're normally out of here by now. Oh. All right, 2 more things. No, I'm joking. Let's get there. That's enough. All right. So hopefully tomorrow